So hey guys, welcome back to today's another video. Today we have given this question, Leetcode 1079, letter tile possibilities. Let's read the question description and understand question better. So the question says you have n tiles where each tile has one lateral tile, so 5 printed on it. In simpler terms, we are just given an array, right? Return the number of possible empty sequences of letter you can make using the letter printed on those tiles, right? So we can say we are given an array and we need to use these characters to generate all the possible subsets and then all their possible permutations, right? So you would see that for AAB I can generate I can generate a B, I can generate an AB, I can generate I can generate, right, an AB, I can generate an ABA, I can generate, right? So these are the only possible cases. Let me just draw them, right? So for ABA string I can generate, right, I can generate I can generate B, I can generate AA, right, and I can generate AB, or maybe I can generate what do I say, ABA, right? So if you would notice, these are the only possible subsets which I can generate, right? These are the only possible subsets which I can have for this string, right? But apart from this, I have to also generate all the possible permutations. So what will be the other permutation possible for this, right? So I can write AB as BA, right, BA, and I can write ABA as AB, or maybe ABA, right? So I can generate these three extra permutations, right? So you can see the total number of permutation I have total number of sets in their permutation I have available is 1 2 3 4 5 6 7 8, and you would see the answer is 8. So we have got the question. Let's now move to how we are going to solve this question, right? I hope you have got the question, right? So given a string right, so given a string, first of all, we can break down this we can break down this problem into two subparts, right? We can break down this problem into two subparts, where in first subpart I have to generate subset, right, and in second subpart I have to generate all all possible permutations, right? All possible permutations of those of elements of subset, right? So this is also how I showed you this example for string a b. Let's see how we can code this, right? So basically we have an idea. We know that if we need to generate a subset, we need to use a recursion and backtracking, and if we need to generate all the possible permutation of a subset, we also need to use a recursion and backtracking. So this question is a purely recursion and backtracking based question, right? So let's see how we can generate all the possible solutions, right? So let's say we have the string, what do I say, a b, right? This is the string given to us, right? So first of all, my pointer would be over at this location, and I will have a choice, right? I can pick this element, or I don't pick this element, right? So if I pick the element, then in that case, right, I would have a case if I pick the element, and I would have a case, just a minute, and I would have a case when I don't pick the element, right? And I would have a case when I don't pick the element. Similarly, if I pick the element, my right, actually just remove this with just like this. Initially we would have an empty set, right? Now my pointer is at just put it over there, right, and just create a string a b and AAB, right? So initially my pointer would be at this location. I would say, hey, I can pick this as string, or I don't pick this letter, right? So if I pick the letter, I would have the string as A, right? I would have the string A, and if I don't pick the letter, then just a minute. And if I don't pick the letter, then I would have and again an empty subset, right? So then my pointer moves to this location, then I again have a choice either to pick that element and either to not pick that element. So if I pick that element, right, so if I pick that element, and if I don't pick that element, and again if I pick that element and if I don't pick that element, right, let me just write them a little wide, right? So we have a proper recursion tree, right? Then I can again pick that element and not pick that element. So if I pick this element, then I would have elements in my set as AA, and if I don't pick the element, then I would have only an empty set A, right? and if I pick the element in this case, then I would have a choice, then I would have a, and if I don't pick the element, then again I would have an empty set, right? No problem with that. Then my pointer moves to this next location, and I would say, hey, I can pick this element, or I don't need to pick this element. The process repeats, right? The process repeats for this case as well, for this case as well, right? For this case as well, I would just, right, just a minute, for this case as well, and then for this case as well, right? Just for this case as well, right? So if I pick this element, then I would have a then I would have my set as a b a b, right? A b, and then I would have, if I don't pick the element, then I would have a. If I pick the element at this part, then I would have, right, then I would have ab, right? Then if I don't pick the element, then I would have only a as my part, right? And if I pick the element in this part, then I would have ab, and if I don't pick, then I would have only a, right? If I pick this element, then I would have b, and if I don't pick this element, then I would have an empty string, right? So you can see, I can just also write, this is the pick part, just a minute, right? That there, if we are going left, then this means we are picking, and if we are not, if we are going right, this means we are not picking, right? So this is a pretty standard question for how we create a subset, right? So we know we have done the subset part, right? So this is the basically a subset part, and we can see that we are generating all the possible substrings, right? And how many possible elements are there possible in the for a string of length, and the total possible number of subsets is 2 to the power n, right? So doing this problem takes a total complexity of o to the power big O of 2 to the power n, right, for a string of length n, right? No problem with that. Now after we have generated this tree, right, after we have generated this subset, I can rewrite this element as, I have subset a, right, I have element, right, we have to ignore the empty one also, actually. Then we have a b, a b, and you can see these values repeat itself, so we have to consider only one of them. So I have considered a b, then a b, right? So these are the possible elements I can get, right? Yes, I can only get these possible elements, ignoring the empty space, right? So this is the possible subset I can get. Now I have to generate all the permutation, right? So how we generate the permutation? Generating a permutation is also a standard question for a given string. Just let me put this side, right? Just a minute, right? Let just put this over there, right? Right, let's come to this side, right? So now we are generating all the possible sub permutation of a subset. So for example, if we have a string a b, let's see how we can generate all the possible permutations, right, for a single element. Then we can do this as a recursive function for another. So it is also a standard tracking problem. So my stack index starts with this index, right? So my pointer starts with this index, and I would say, hey, I have a choice either to swap it with the current element, or if I don't swap it with the next element, right? I would check for all these elements and I would swap, right? So if I swap with the, so my let's actually just create another pointer, right? So my another pointer is also locating at this point, right? This is my the one which I am replacing, swapping it with. So say if I swap, right? So if I swap, right, just a minute. So this would be if I swap, right, and this would be if I don't swap, right? Comparing, I'm swapping with this pointer, right? So if I swap this variable, then again I'm gonna get a b, but the key difference would be that the pointer which I'm considering reference would move to the next location. What I'm trying to say, just copy this, right? So what I'm trying to say, if I didn't swap, but my pointer moves to this location, right? Now I would consider swapping it with this variable, right? So if I don't swap with this variable, then I would check, right? Then just a minute. Then if I don't swap, right? If I don't swap, then again I would have a choice, right? Again I would have a choice that either I swap it with this variable, either I swap this location with this part, or I don't swap it with this part, right? Then again my pointer moves, then this will just repeat, right? So let's create a whole array. Let's create the whole, then I will show you how it's actually working. Just let me create. Okay, so I have drawn all those possible subcases, and you can see, let me just zoom in a little bit and try to understand you, right? So basically we run a loop for each index, right? So currently my main pointer is at 0th index, and we say, hey, we can either swap it with the current variable or we don't swap it. So what happens if we swap those variables? We can see that nothing is gonna change, but a main pointer moves to the next index. Same process again repeats. I can either swap it or I don't need to swap it, right? So if I swap it, what happens? Nothing's gonna change, and I move on to the next pointers. Then again I can say I can swap it with the same variable, and if I swap it, nothing's gonna change. But in case if I don't swap it, the pointer would move to this orange pointer, which is a loops pointer, would move to the next location. There's no next place. Then the red pointer would move to the next location. There's no next place. That's why this is one of my final permutation, right? Then again it will backtrack, right? Then it will again backtrack. Then it will come at this location. You can say, hey, let's say if I don't swap at this location and I need to swap at this location, then it would come at this case, right? Then it would come at this case. Then it would say, hey, I can swap this variable. Let's say it swapped these two position. So if it swapped these to the position, the red pointer would move to the main pointer would move to the next index, right? So and it would say, hey, I can either move, I can swap it or not. So even if it swaps it, if it don't swap it, again becomes the same case, and it in the both cases it generates the string ABA, right? Then it backtracks, and it say, hey, let's say I don't need to swap it. I say I swap it with the next variable, but there's no next variable, so the red pointer moves to the next location, and you can see the case repeats itself. That's why I have marked it with a red circle, that these two are the same subtrees, right? Similarly, I have also marked the final answers with this blue rectangular boxes, that these are one of my permutation which we have got in the results, right? Similarly, then it will backtrack, then it will say, okay, let's consider this point where I swapped initially, and say I don't swap it with this, I need to swap with the next variable. Okay, say if I swap it with the next position, then what happens is nothing's gonna change, right? If nothing's gonna change, what happens? If I swap it, the next pointer also moves to the next location. This should be a red pointer if it's visible, right? So it points to the next location, and you can see this case has already been processed, so we don't so basically it's just the same subtree we are gonna get over here, so I haven't drawn that. Then in case if we don't swap it, then we say, let's say we swap it with the third position, right? So if we swap it with the third position, we can say we got this string, right? And the red pointer moves to the next location. Now from here on, if you swap it or not swap it, you are all of the subtrees, you are gonna get this string as your final answer, right? If you swap it with the A, if you don't swap it with A, that's why I've used multiple arrows, that in all the cases you are going to get this string, right? So this is also one of my final answer. So you can, and for non-swap case, it would come at this case, and you can see this case is already in process. It's the same process, right? Same process, right? So I think you have got the pretty basic idea what we are going to do. So first of all, we are going to generate all the subsets, right? So first of we can generate all the subsets in 2 to the power n complexity, O of big O of 2 to the power n complexity. And for this, for a string of length n, there can be n factorial permutations, right? There can be n factorial permutations, right? So generating all possible permutation of a particular strings of a particular string, right? Of a particular string takes n of n factorial time, but since we are doing it for all 2 to the power n strings where we get an overall complexity of big O of 2 to the power n multiplied by n factorial, right? So this is the overall complexity. Let's also code this problem and let's see how this works. All right, so let me just code it. So I have coded this video, so I have coded the solution pretty quickly. You can see the first solution is where basically I do what this is doing. So first there's one method which generates all the subset, and there's one method which generates all the permutations, right? And I have created a set which stores the unique strings, and I have also created a swap function which is basically swapping these two variables in the string builder. So what I do is let's go through the code and explain it, right? So what I do is I will create a string and I will generate all the subsets, right? I will generate all the subsets, and in the end I'm just returning all the let's just ignore this for now and say we are generating all the subsets, right? So how we are generating a subset? The generate subset takes the tile value, which is originally the string, the current set, right? The current set. If you notice, if we need to generate all of the subset, we are getting these all of the subset, right? Similarly, what is it, those subsets value, right? These string values are stored in this answer variable, and index points, the index is this variable which points which variable currently we are considering in our case, right? So at each position, let's ignore this part, we have an option either to not pick. If we don't pick, then we just move on to the next index, right? That's why I just passed the tiles value answer variant passed on to for the next index, right? And what I do the next is, next if we consider that element, if I consider that element, then I would add that character into my answer variable. So I've appended that variable in my answer variable, then at character index, then I generate subset because I have picked the element, then I generate subset for the next indexes. And if and while backtracking, I remove that character. That's why I've done delete caret answer dot length -1, which is basically removing the last character, because last character was the one which we inside. Then it generates all the subsets, and when the recursion ends when the pointer has moved out of index, right? So when the index is equal to the tiles of length, that means the index has moved out of the pointer. First of all, we check if the answer dot length is 0, right? Because we don't need to consider this empty string. So if the answer dot length is 0, we don't do anything. But if the answer is not equal to 0, so let's then we have got one of these string as a permutation, right? Then we have got one of these string as a permutation, as a string, as a subset, right? Then what I do is I will say, okay, generate all those permutation of this current string. Then I pass this string into the another method, which is generate permutation method. So what this generate permutation method does is, the generate permutation method basically does is it takes the string in the index currently we are focusing it, just how we explained it, right? So the red pointer is basically the index pointer which I am considering over here. So let's ignore this part for now and see what I am doing. So starting from index, notice how this basically, this brown pointer is basically a loop pointer, just as I explained earlier. So I have an option. I swap this variable, okay, right? I swap this variable and say, let's say if I swap the variable, what would be the next permutation? So I need to update the index plus when I say, okay, let's do the recursion for the next part, right? And while not to backtrack, right? To backtrack for the not swap case, I'm again reswapping those variables, right? And again reswapping this variable. And how this swap function is working, you can see it over here, that it basically takes a string s, the integer I and j in which I need to swap, and it's a basic standard swap function which you can build by yourself. There's no problem in that, right? And when this recursion ends, when the index reaches out of the bound, that means we have generated a string, right? We have generated a permutation. So basically we convert that to the string, and if the string, and we add that to the, we can actually just rewrite it as like this, right? I was doing it wrong, sorry, right? So basically it's a set, so there's no need to worry about it already being contained. So I've created a head set, so it inserts that string into our set, and we just in the last we return the unique strings dot sides, right? Let's see how it works. So it runs, and if you accept it, we got an accepted solution, we will get in, right? You can see we get an accepted solution. But this is not the only solution, there are actually two more methods, right? There are actually two more methods in which we can solve it. So the one other way is to do both the operation, right? Both the operation, generating the subset and generating the permutation at once. We can do this by creating a function, by creating a method which generates the sequence, and also generates all the permutations of it, right? Which and also generates all the permutations of it while going through the operation, right? So how this is going to work, let me just write it down and just show you pretty quickly. So I've coded the solution, so you can see what I'm doing. So this is the main function which we are given. So I'm generating a string. Obviously we have to generate a string to maintain all those strings. Then we are creating a string just like in the previous solution. Now we are creating a used variable, right? So what we are doing is we are creating a used variable. So what happens is how I'm going to generate the permutation is, so basically I've created a pointer, right? So I've created an array. So if I haven't used it, right? So if I haven't used it, then either I can use it and I don't need to use it, right? Then again, when I come to the when I move to the next location, if I have used it, then I can use it, or I don't need to use it. It's a standard pick and not pick problem. So what you would see is I've created a function generate, which generates all the permutation while it's going. So what happens is, just let's see in the code. So this takes the main answer variable, the string tile, and the unique string is set so that it can insert it in the set. And in the last time returning unique string dot size -1. Why -1? Because we don't need to include this empty string, right? So let's see how this code works. So basically you would see that at every case, right? At every case I have let me draw the whole tree once, right? So I have done this part. So let me tell you what I'm trying to say. So my string is ab, right? So my pointer starts at this location, right? So my pointer starts at this location. I have a choice, right? I have a choice either to pick that element and not pick that element. So if I pick that element, then I would have a corresponding array, right? I would have a corresponding array which would say originally all those values are 0, right? I haven't picked any value, right? That's what my used array is doing. So if I pick that element, my element is marked as 1. Then again my pointer says, then what happens is, then I come to the next point, then this is one of my string, right? This is one of my substring, right? So what I would say, then again I would say, hey, I can use this here, but I would see that it has been marked with 1, right? So I would move on to the next pointer. I can say, hey, if I can use it, right? So if I can use it, then then it will mark as 1, right? Then again I will come to the next place. Then the next iteration again starts. I would say, hey, if I can take it, if I can take it, if I can take it, it would say yes, I can take it at B, right? So it would generate A, B as a substring, right? So you can see by doing so, at each iteration we may insert, right? At this part you would notice just where it is. Just a minute. So basically what I was trying to say, this isn't going to stop it just here at just this level. Why it isn't going to stop at this level? Because again we would have an opinion to again insert that element, right? Again insert that element. So if I insert element after this, because I can see a 0 available over there, so I would insert a after the B, then it would generate a B. So you can see that this recursive code is gonna generate all the permutations while it is generating the subset, right? If you got my point. So that is basically what I was doing. So basically at each step I would insert that string. I would insert the string because this is also one of my subset, right? In that I'm just gonna get all those possible subset of string size 3, right, for a b. So what happens is I'm going to insert all those str.toString to unique strings, right? And if I haven't used that variable, the variable is marked false, right? I have created it as boolean, right? Then use it, append it to the string, then generate all the possible cases again, right? Again generate all the possible cases. If it don't generate, then after the backtrack, remove that last character and must use as false. If talking about the time complexity, since we are generating all those possible cases, right? Its time complexity is gonna go up to a big O of 2 to the power n, and multiplied by n, right? So this is quite less than 2 to the power n to multiplied by n factorial. So you would see this also rain, and when I submit it, it would also get submit, right? And it got submitted, right? So I think you have got the pretty basics solutions and how this works. However, there's two more method. One is a mathematical method which you can read on the editorial, and there is one more method, character count method, which solves the problem it solves a problem in big O of n factorial. So obviously 2 to the power into n multiplied by n is much less for n factorial. So we are sticking with 2 to the power n into n factorial, not going for the O of n factorial solution. But if you want to read it, you can read it in the editorial. I hope you liked the video. If you have got any doubt, please let me know in the comment section. Have a good day. Bye bye.